So hello everyone, welcome back to the video series, and we have already understood about what is agility, what is agile process, and now we are going to see what is extreme programming, which with different framework activities that are followed in extreme programming. So let us start discussing one of each and every type of activity here. So in this slide, in this particular uh, slide, we can see a diagram which actually resembles similar to what we have seen in unified process. We actually have removed the construction, the communication phase. So it starts with planning. Planning actually has these set of activities. The planning starts with something called as user stories. The user stories generally are the terms or the scenarios that are narrated by the customer, and each of the company members or the development team member has to listen to this user stories. Based on the user stories, you actually takes down certain values. These values are the requirements, okay, that you actually wants to drive. So these are the requirements that you take out, and you actually also take out you also based on the requirements you actually do the planning activity, okay. You actually do the planning as well. Now based on these two things also, after that you need to have acceptance criteria. This acceptance criteria actually tells you then that if I develop this requirement, whether this requirement will be accepted or not. Okay, this will be a particular activity. It defines the scope of the requirement. So if I say that I develop a login screen, suppose my requirement is to develop a login screen. The login screen that generally has a username, okay, and a password. I suppose there is a submit button. So this is a submit button, this is the username, and this is a password. Okay, so it says that what all things I need to do before I accept this small workflow of a login screen. Suppose, so what I do is I will create a table like username and password. So I will say that when my username is correct and the password is correct, the submit button should work as it intended to do, right? When my username is wrong and password is correct, this submit button should not work. Ideally, it should give me a proper error. Likewise, when a username is correct, password is wrong, this submit button again should not work. And when this username is wrong and password is wrong, this submit button should actually don't work. So these are the invalid scenario. This is only one valid scenario. Okay, this is what it actually means. Now we will actually use this acceptance criteria in this acceptance testing, right? Because we have classified that these are the criteria on which we are going to judge the requirements, okay, on the final product. And requirements are those things on based on which the product is being developed. So this is a cycle. It's cycle. You cannot say something. These are the independent stages. So it's a cycle. It says that once you develop all these things, acceptance criteria at the initial phases, we don't have design, we don't have coding, but we are developing the acceptance of the requirements right now. Okay, and we will adhere to the acceptance cases or this criteria during the development of the product. Okay, so this is a very intensive or a communication based practice, and you have to do it very judiciously. Now the second thing is, and finally you also have an iteration plan. Then in how many iterations you are going to develop this core product, in what iterations you are going to develop the first prototype, the second prototype, and something like this. So all these thing is done in this particular in this particular what you can say in this particular stage of user stories or planning. Now let's understand the second stage, which is known as simple simple designs or CRC cards. Now simple design generally means that means you create simple models with help of the designing of different things. We will use here different type of UML diagrams. Okay, we will actually use something called UML diagrams. In this phase, we create UML design using UML diagrams, and we also have something called CRC card. CRC card, will look into it more closely when we discuss about requirement engineering. But as I now understand, this CRC means class. This is a class. This R represents responsibility, and this is C is for collaborators. Okay, so that means every, because this is an object oriented based approach, we talk about class. Each class that you create must have its own responsibilities, right? That means if I have a login class is to have the proper mechanism of why it allows you to enter username, it allows you to enter a password in a hidden form, it also has certain functionality that it uses. But this class of login cannot work on its own. It cannot validate a username and password. Okay, he can do only some validations, that the password should be of a particular regular expression, like it could have uppercase and lowercase, a special character, or number of digits, or number of length of the password should be 8 or 10 or 12, whatever. These are the primary validations that can be done by this class. But sometimes happens, it will actually, you have to go to another class, the class of connections, and that means it will go to database, verify whether the username has the actual password or not. This is not the work of the login class. Okay, login class has to collaborate with some other classes where it wants to take a value that yes, this is valid, now go and proceed, now go and display this error, now don't display this error. So these collaborators generally are classes. Okay, these collaborators are also classes, but these classes actually work and provide certain data to the primary class. Okay, so I have a class here which is the primary class. This class collaborate with other classes to actually does his responsibility. So he want to do his responsibility. This class want to do his responsibility, but the problem is he cannot do his responsibility on his own alone. Okay, so this class needs help from another class, and that help is known as collaboration. Okay, so these are CRC cards. So we will see these, what are CRC cards in our normal what you can say next level design. What you can say next level uh, requirement engineering. Okay, when we discuss about requirement engineering, we will see these things. Now the next thing is called spike solution prototypes. Spike solution prototypes generally are what is spike solutions? Spike solution, generally spike means a certain set of you can say a certain set of data coming, like I am working on this once. I am working on this particular line. Suppose I am working on this and suddenly I have an issue. So it comes like this, it again go, then I have another spike, then I have another spike. So these things are called as spikes. Okay. Now these spikes can be visualized as problems. Okay. It can be visualized as problems or issues or bugs or errors. Okay, whatever is the name given, these spikes can be anything: a problem, an issue, a bug, or an error. Okay, so whatever the thing is, we need to spend certain amount of time thinking about the problem, the issues, the solution to the problems or the issues, and how we are going to resolve it. And sometimes we don't have a concrete plan, so we develop certain prototypes to demonstrate that this is the proper solution of the problem. So we need to have certain, at the designing level, we need to have certain spike solution, a solution to the problem in form of small prototypes. Now the next thing is called coding. Next is called coding. In this coding, there are two things. One is called pair programming, another is called refactoring. Sometimes it happens that you actually have a code, you actually have this code, and with this code, we are not able to understand certain aspect of the code itself. So what you need to write it in a proper fashion, or you can say that I am going to deliver a product. The first of all, I am a person who is who has created, who is going to create a particular scenario, a particular new product. So what I will do, I will start it in a fresh file. I keep on adding code as and when it is required, right? I code something here, then again what I do, I code something new here, then I again start coding it, I code something else here, right? I code something else here. So I keep on adding codes as and when it is required. Keep on writing the code as and when it is required. So, but this is this is my file. I understand everything. I know everything. Where it is written, why it is written, and what is the purpose this code is going to do. But if I ask you to change the code, it's very difficult for you, because sometimes this process, this can be the input variables, or this can be some output variables, right? Then this red thing can be some processing element. Okay, now this type of things happens to be in a file. It can be at multiple places. So what is a logical way of writing a code? That logical way can be, you can have a proper file structure in which you have three sections. This section, all the codes that are doing input processing should be there. This is the code where all the processes reside, and this is the code where all the output functions should reside. So in case you have a issue with the input processing in your software, you don't have to look all the softwares, all the places in the software. You actually go and look only this section of the code. If your data is been captured properly in the input phase, is not processing it properly, you're not getting the output, the problem can lie in these two set of structure, right? You don't have to run through all the codes. So this is known as refactoring of the code, and sometimes refactoring actually resolve the issue much better than writing a new code. You refactor it properly, and you are now in a better state of reading the code and developing your code. Now, next thing is called pair programming. In pair programming, what it happens is it as the name suggests, it has a pair of user. Okay, the pair of developer actually has it can have an experienced developer and what you can say unexperienced developer, or it can also have both experienced developers. It can also have, so pair generally means two, right? They are two peoples, one and two, they work together. So sometimes this person writes the code and this person only reads the code. That means whenever other person is reading it, it can find errors easily, because one, the person who is writing it actually is focusing on what he's going to write and how it's going to write, right? This is what it actually goes through. So in extreme programming, one person actually reads. Sometimes he can be a reader and this can be a writer. So at this on in this type of scenarios, in fixing a issue or learning is high prioritized. So this person which is reading, if it is immature, it's new, he is going to learn. Okay, and if this person who is immature is going to read, or this person who is experienced is going to read, and he will be providing you with the expert advice. Okay, expert advice, he may also learn, but he may provide you better advice. So the thing is, in both the cases there is continuous learning going on. At the same time, you are going to find more numbers of issues with the same pair programming concept. So pair programming is a very strong concept which actually goes in the industry in type of training an employee, it finding more issues, in trying of creating two minds discussing the same problem, comes up with a proper solution. There isn't one mind. Now the next thing is called continuous integration. At the same time, because this is the agile process, so it needs continuous development, the CDRs. So that means you need to, whenever whatever you develop in the coding phase, you need to do a unit testing also every time, and then followed by unit testing, you are going to do an acceptance testing. As we have said that this acceptance test goes with the test criteria. So once you are done with this testing part, you release the code to the customer in form of software increments, and the next product velocity is now computed. Now based on this first extreme programming concept, you are not going to assess what is the velocity required, what is the speed you require to do the next increment or the upcoming increments. This is what it is meant by extreme programming. So this is all about extreme programming in this short video of 15 minutes. We are going to learn about another concept which is known as Scrum programming, and what is the Scrum based model, which is one of the leading standards of software full stack developer, right? And then it needed that you need to be a Scrum master, you have a certification of Scrum master or not. So we will see what is Scrum and what is the basic elements that are comes into the Scrum based programming in our next video. So stay tuned. Thank you very much.